This video is just a quick demo on the equipment that we're going to use in the labs. We have here the oscilloscope or function generator. It's going to be implemented by DigiLint Analog Discovery. I have the card so we can see more or less the size of the device. It comes with a USB cable, an interface for analog and digital pins, which is also portable and small. And it comes with two oscilloscope probes that can be connected to the analog inputs of the oscilloscope. We have multimeters available. We don't need to have expensive ones. $10, $15 ones are more than enough for what we do in classes. And for this specific demo, we're going to cover the board for the digital design class, which is again a portable board that is capable of doing a lot of stuff. It has an FPGA inside, a couple of buttons, some LEDs, 7-segment displays, and some I/O to interface with Raspberry Pi and Arduino boards or any other microprocessor. It comes with a USB cable, and let's just see these in action. Let's go over how to connect all these equipment together. We start with the oscilloscope and the expansion board, and there is only one way of connecting these together. Once it's connected together, you're going to connect the oscilloscope with a USB cable to your computer. Regarding the probes, you have two analog inputs and two analog outputs. I'm going to use the analog inputs because I want to use the oscilloscope mode, not the function generator. And then I connect my FPGA using a USB cable to my computer. And everything is ready to be used. I don't need that second probe. And that's pretty much it. Let's go over our first project using the equipment that we just connected together. This is the equipment that can be used for second year sophomore class, the digital design. The only thing that it's missing is the power supply, but the oscilloscope and the board, we have them here. We're going to go into the software that we use to program the board. And here we can pretty much implement anything that we want digital wise. We can have blocks with circuits inside that can be used in our main design, and students can design anything here. I'm going to program the board, and the program is just using a 50 megahertz clock and reducing to a 1 second, so we can see an LED blinking and then showing a countdown on a 7-segment display. We're going to detect the board, pick the specific board that we're using, and load the program inside of the board. And once it's done, you will be seeing the 7-segment display showing the countdown and also an LED blinking at 1 second. And we had a couple of logic gates over there, AND and OR gates, so we have buttons, and the buttons are just doing the respective logic, so they can do anything that they want with this board. And this is an example, a simple example, the Hello World example for the board. At last, we're going to see how can we use this equipment and in conjunction with oscilloscope. We need 2 wires. We're going to connect one wire to a reference point, in this case ground on our board, and then ground on our oscilloscope, and another wire to a GPIO pin, in this case pin 35, and connected to the probe, to the oscilloscope probe. Then I'm going to the software and I'm going to deploy the code. I already added the pin. Pin is connected to the output of 1 second, the LED. So we're going to see the wave coming out of the LED. We upload the code. It's doing exactly the same thing as before. We have the 7-segment display showing the numbers, the LED blinking, and the oscilloscope connected to the LED. Now I'm going to turn on my oscilloscope software, waveforms, and I press scope. And in this particular case, I'm using channel number 1. So I don't need channel number 2. I'm going to disable it, put the trigger a little bit higher so we can get a stable wave, play around with some parameters, adjust it to the time that I need, and here you go. You have the wave coming out of the LED.